Hello, this is John Wen. A developmental method that computes optimal networks without post-selections. I submit a report to Nature about 15 AI papers since 2015 in Nature at a problem of protocols known as post-selection using test set. You can find out my report at the link here. What is a post-selection? When trains N networks and could be large, initialized by random weights, there are three types. Type 1 uses validation sets, post-selection using validation sets, PSUVS. It is bad because report only the luckiest one among N networks without N-fold cross-validation. It is also bad because the luckiest network reported on a new validation set, the luckiest network only gives expected average error of all trained networks. The remaining N-1 networks was not reported. Type 2, using test set, it's bad like type 1, but even worse, is you test on the training data. Type 3 uses PSUTS by humans. For more detailed, read the paper on IJCN this year. There is a debate on the PubPeer about deep learning net paper, and Graves et al. About hybrid computing, and Li Feifei's work, PhD work, at the journal paper in PEMI. The post-selection is rooted in lack of competition, mainly. Without competition on the right, and the error back prop as the neuron connected, random collected to help, but the neuron does not have a role assignment. With competition, roles of each neuron is automatically derived from competition. For more detail, see the IJCN paper. The formulation of optimal maximum likelihood compute only one network without need any post-selections. The maximum likelihood is from observation. You have huge number of network parameters, internal representation, and motor neuron, and random weights. And that's an unsolvable problem. And that's how post-selection relies on luck. But our framework is unfolding time, through time, then each time only take input from last time, and T-1 will be used for T, and T will be used for T+1. Then the highly complex, high-dimensional nonlinear function of searching had a closed form solution represented by context XYZ at T-1 as a closed form solution to compute the optimal parameters for T without doing iteration at all. It's a beautiful selection for computing optimal network without post-selections, and implement conceptually a universal Hilbert Turing machine that's a maximum likelihood optimal. The developmental network computes average error for each time T from birth time 0. The number of hyperparameters is 1, and the number of random weights is 1. LCA computes the optimal network without bothering by randomly initialized weights because retention rate is 0. For more information, read the paper. And this is a comparison of performance difference. The lattice network from CNN goes down very slowly, and our optimal network, only one, already reached optimal in epoch 1, but the lattice network from many other networks do not go down at all, like learning garbage. But by the time it reached 500 epochs through the data, and the error is still considerably higher than the optimal network, they already reached optimal error at epoch 1, and at epoch 500, the lattice network still is higher than the optimal network in terms of error. Thank you very much.